derive the equation for dVout over dVin of this common emitter amplifier circuit right here. We know that this is a common emitter amplifier because the emitter, which is here, is immediately shorted to ground, thereby it being called common emitter. However, we also need to make sure that we know that this is the base over here connected to Vin, and right up here we have the collector, which is connected to both RC and Vout. So now that we know this is a common emitter amplifier, all we need to do is generate an equation in which we include Vout, thereby applying a derivative with respect to dVin, and we get our solution. So we can see here, if we apply simple KVL, we can have an equation with Vout. We know that Vout is VCC minus RC times the current going through RC, IC, you could call it. IC meaning the current through the collector. So we can say that Vout equals the difference, VCC, minus, using Ohm's law, IC times RC, where again, IC is the collector current. Now that we have that established, we need to change some variables around, because of course, it can't be that easy. So, we also need to understand that we have a couple other formulas where IC equals saturation current IS E to the VBE over VT, where VBE is the potential difference between the base up here and the emitter down here. And VT is thermal voltage, which is 26 millivolts roughly, so you don't have to worry about where we're getting that from. But this is a small signal analysis formula that you'll see throughout the entire analog course anyways, so get used to it now. And lastly, we know that transconductance of this transistor, GM, equals IC over VT. Just another formula you need to know. Having that in mind, let's start modifying this formula a bit. We can see that Vout equals, again, VCC minus IC, which we can substitute with this formula, IS E, and we want to have it in regard to Vin, because VBE is, as you can see, the voltage at Vin minus VE, which is just ground, so that's just Vin over VT, all times RC. Now, all we have to do is take the derivative of Vout with respect to Vin. See, if we didn't change this formula, we would have just gone 0 on the right side, so that would have been absolutely useless. So, dVout over dVin equals, well, we know since the independent variable of this derivative is Vin, VCC is not Vin, it's a constant, so that's automatically 0. And we know that RC will be the coefficient of this huge term here. So let's just write RC on the side. And I know it's kind of weird putting it on the right automatically, but it'll make sense why I did that. And we can see that the independent variable Vin over here is in the E exponent. So we know we're going to have to do a little bit of work over there. So first, we know that since the variable is here, let's put the constant in front, negative IS. And taking the derivative of Vin over Vt with respect to Vin is like the same thing as saying d dx of x over, let's say, 3, which as we know is 1/3. Same thing applies here. Taking the derivative of e to the Vn over Vt with respect to Vn is simply 1 over Vt. Multiplying that by this coefficient, you get negative Is over Vt. And as you know, nothing else changes about the e, so it's still e to the Vn over Vt. And there you go. We have our finished product of this derivative. However, we can make it look a little nicer. This is technically a correct answer, but in regard to what they usually want you to say in textbooks, will be moving over here, dVout over dVin equals, we can see here that GM transconductance equals IC over VT, and we know that IC equals ISE to the VBE over VT, or Vn over VT. So we can take this entire term over here, plug that into IC, and we can see that entire term over here. So it'd be negative, and this also accounts for the VT denominator. So this entire term over here becomes negative GM. Do you agree with that? Hopefully you do. So it's negative GM times whatever is left, RC. So you do actually see this formula around this course as well. And as it turns out, that is the final answer. This is the most simplified version of what you can get from this common emitter amplifier. So if you have any questions, please leave in the comments below, and good luck.